All right, then I will get started. As it was told to me, slowly getting started, slowly get the things rolling. My name is Max Körbächer. I'm the founder and managing director of Liquid Reply. That's the part where I own the money for my bread and butter in the morning or the cat food for my cat. But beside that, I have a couple of almost hobby projects around open source. I was contributor in Kubernetes for almost 3 years. I've started and initiated the technical advisory group for environmental sustainability within the Cloud Native Computing Foundation. And I'm also organizing other events like the KZD Munich and stuff like that. And through that, I became the CNCF ambassador and also have now the honor to be part of the Linux Foundation Europe advisory board. So that's about all the open source stuff, but let's get right into the topic. So talking about green cloud or cloud computing itself, you have maybe heard in the last days a lot about it, at least from Matt. He stated a couple of interesting numbers. For example, that if you put all the data centers together which you have around the globe, it will consume around 420 terawatt of electricity. That's more or less the size of Germany. And there's also some expectations that this will grow almost by 100% in the next years. Now, the thing is, it's not very precise and clear study. Unfortunately, the same numbers we had like 5 years ago, and the predictions for it are somewhere between like, oh, it will grow just by 2% and just as good, or all this AI data, bringing stuff on the edge, increasing network communication, distributing the workload, and so on and so forth, will cause that maybe IT goes up to consumption of 10 or 12%. But that would be insane, right? Just to make it a little bit more clear, what does cloud really cost us is the same amount of carbon footprint as we have for construction industry, looking at a pretty nice new building outside the window. Building that thing is more harmful than any kind of data center which you have all with the GPUs, or traveling around with airplane, but the whole airplane industry, right? So these three things are practically equal in the amount of carbon footprint cost. And coming to that, often there's a question, is cloud a solution for that? Can cloud help us? And the answer to it is no, actually not. It can help companies who do not have the power or capability to build their own data centers in a way that they're highly efficient and really can be utilized to almost 100%. When you don't have this capability, then cloud could be a very good answer for you, because it gives away or takes away all the overhead, all the headache which you have constructing something which is supporting your optimization journey, I would call it. So, as a good consultant, I need to say it depends on, obviously. The good thing which we can always consider in our head is some topic about energy proportionality. We can discuss about how accurate this is, but what it practically says is like, if you have a server and you want to utilize the CPU which you have on the server for 50%, then you, for example, need 180 watt to run this 50% CPU utilization. If you scale this utilization up to 100%, it just costs you 20 watt more. With newer servers, these numbers are turned a little bit more down. They're not at linear level, but coming close to it. But the reality is, most of the server which we have are on this level of energy proportionality. And all data center providers or cloud providers have announced that they extend the lifetime of their servers by at least 2 to 3 years. Means that we have this still going on and we still have this running more and more. What it means for us is, we should stop to over-provision virtual machines and servers which we have. We always need to utilize them to 100% where possible. And for this, for example, Kubernetes can help. It's not always the answer. As we heard earlier this morning from Kelsey, if you run a website, don't start running it on Kubernetes. That's absolute nonsense. But if you're a little bit grown and you have a couple of applications which fit into this context and which can run in this context, it might be able to help you to fill up the space and go to 100% of utilization. without that you have the fear of running out of resources. This is the one side of the journey. Optimize the utilization as much as possible. The other side is you need to cut down the unnecessary things. And I can promise you I can go to any kind of enterprise or large-scale company and cut down 30% of the IT and nothing will happen. Why I can say this? Because that's what we often do. We have a department which is focusing on the engineering part. We have a department that is focusing on the financial optimization of cloud costs and what is connected to it. And it is connected also with reducing the carbon footprint. By following the simple R's, reducing, removing, right-sizing, maybe re-platform, maybe relocate, maybe refactor, you can cut down a lot of your internal deployments. And it will not harm anything to your business. You will not lose anything in your reliability, you will not lose anything in your high availability or stability or whatever. What we often find is that if you have containers in Kubernetes, for example, you have something that's called kube sprawl or container sprawl. Means you have somewhere things running that are completely disconnected with your whole deployment pipeline and living somewhere in your server ecosystem and running around and consuming something. Sounds like a problem which should exist. It's usually one of the largest problems which we very fast identify, that there's some stuff existing that no one is using and it's just like lives this happy life. Sometimes it even receives some updates, but still no one uses it. So my smart answer to how we can come to optimize and be better in our cloud computing is just use your brain. It sounds like a stupid thing, but when we observe large companies migrating everything what they have to the cloud, they want to do this as fast as possible, right? It's a project what they are doing. That means they have a deadline, they have a fixed budget, and they need to be as fast as possible to go somewhere. Reality is, if you do one-to-one migration to the cloud, it becomes more expensive. Means your budget is burning faster, mean that you do not have budget to refactor, to reduce, remove, right-size, re-platform, and so on and so forth. You have no money left over to optimize for the other things which maybe are more relevant for you. So if you do migration, if you consider to move somewhere else and to optimize something, it sometimes just helps to think it a little bit through. You do not need 99.99999% of availability of a service. You anyhow will not get it because the most cloud providers will not go below above 99.95, right? So to shortly summarize this, we have to maximize the consumption and the utilization to be more efficient with all the resources which we have. How we can do this? So we have a couple of strategies that allows us to work more on the deployment, software deployment, scheduling level. We have topics around hardware, location, architecture, CPU architecture, not the software architecture. It's, as I would say, often things like which you can touch, right? It's things where you can more or less have a feeling about, I'm hosting in Frankfurt, I'm going to Sweden, whatsoever. We're talking about the system architecture. Usually it's a little bit more complicated to change the architecture of an existing system. But for everything what you're going to build new, you should spend some more time in the evaluation process. And last but not least, we're also talking about optimization of the software optimization and the build process. Problem here is, and that's why we do not rate this so more efficient, is there's this myth about programming languages, you should go for C, C++, Go, Rust, whatever, because Python, TypeScript, and so on is super inefficient. There's this very famous chart about the energy consumption of programming language. That stuff is 8 years old. And when it was done, the programming language were already outdated. So the numbers are still in context right, but the difference is not that big as it looks like today. So refactoring completely a software takes too much time, effort, and money, and is not very efficient. Change the way how you deploy software, super fast, easy to be done. Change the location, the hardware, not a problem. Architecture, it's get difficult. Software, screw it. At the moment, too expensive to do. So when we look into location, there's actually just two metrics which are very relevant. If you want to decide where you go with your software, to which location, depends on if the carbon footprint which someone communicates to you is location-based or market-based. Location-based means you get the actual information of your carbon footprint and the mixture for the area where your data center is located and where your software is running into. So you can do a one-to-one connection. Market-based means someone bought the electricity beforehand for a certain amount of money and with a certain amount of carbon footprint. No one guarantees you that this will be true, because you cannot be legally held on that you have to use more gas, more oil, more whatever for electricity. Not everyone is giving you this information. For the big cloud providers, location-based is just given by Google Cloud. Azure is doing so la la, AWS not. How about Civo?
How about what?
If you give carbon mix based on location or market?
Yeah, we have regions where you can work with
Yeah.
optimized for carbon footprint, yeah.
Okay, so with Civo you can go more like, it's somewhere more close to a location. But this is fine, because if you have already the information for a country, that's more preciser than just like a random energy contract. Here's an example. Good old Germany, not that good. This was taken yesterday. You can see it could be very, very much better. Our friends in Sweden, awesome, fantastic. For the same amount of energy, they have a huge, huge difference in it. Ireland, super famous for most companies to run some workload there for some reason, Texas. And you can see difference here is not that much. It's way bigger than for Sweden, but it's only estimated. What means they do not measure it. Where in some places estimations is okay, for this data, we really would like to have measured, because the big sum thingy doesn't help me. Then I can say, okay, Germany is always around 181, I have a good feeling about it. There are days where Germany becomes as brown as Poland in this case, which have like 300-400 grams per kilowatt hour. Now, the interesting part is that also the amount of carbon doesn't need to relate to the price. So I looked up the energy price. This is the first number. You can see Germany, well, welcome, we are super expensive. Sweden, that's a good price, I would say. And Ireland, somewhere in between. The price beneath it is the same server type for the different region. And when you're careful about it, it doesn't correlate. You pay less for a server in Ireland, where the energy price is higher than in Sweden. So the energy price is not the driver for the price of your server. Yeah. What I want to say with this is also, you cannot just look into financials to optimize your infrastructure and then say like, oh, I've optimized also my carbon footprint. That's not the truth, not always. So there are a few very nice locations around the planet where I can always recommend you to go. Most of them don't have really a data center, but hey, still would recommend you to visit Norway, for example. Beautiful country. But in the second row, we can see like countries like Sweden, Switzerland, and so on. They come with also a very good energy mix. And it sometimes really makes sense beforehand to think about your architecture, where you would like to deploy your application. Because if I want to deploy something in Germany, and you can see this is some data from last year, that's not good at all. That's very shitty, sorry to say. Or you can go to Sweden, which is higher than what we saw yesterday, but it's still 92% better. Right? And this is more or less always like that. Another big important thing when we talk about cloud computing and green cloud computing is to create transparency. Because only if we have a transparency, we can create awareness, and when we are aware, we can start taking informed decisions. If one of those things is missing, I can't decide what I should do. I have then just like the big blog posts out there telling me, go to that place or do something like this one, it might help you. But if you cannot really see it, what does it helps you to have a general recommendation? Sometimes it doesn't fit with your application, for example. You get decently good dashboards from your cloud provider. Always handle them with care, for one good reason. Most of them give you energy data from last year. Not the amount of used energy, but the carbon footprint of your energy. And this can drastically change, right? If you have a super sunny but also super windy year in Germany, the CO2 footprint is not that horrible. If you have a summer like today, it looks totally different. So it's not good to run in this way. You can do it by yourself. You can implement something like Kepler for Kubernetes or Scafandre for virtual machines. They are very helpful in giving you more or less precise insights to your workload and how much energy they use, and you can connect it also to find out the carbon footprint. Handle these things by care. They are difficult to run in production, sometimes are not very completed. And also Kepler has one dirty downside. It used to train power model, AI, to give you an estimation about the potential energy usage when you're running on a hypervisor. So who's running on a cloud? You're running on a hypervisor, most likely. You just use an AI model which more or less predicts you that you maybe use that amount of energy, right? So all around this topic, you always have to handle it a little bit with care, but it gives you direction. So be aware of, like, it has some downsides, it has some uncertainties, but it's better than to be completely blind. We have millions of ways, and yes, this is just like 7 or so, to optimize then our workload. This is now very Kubernetes focused. And you will say like, hey, this is nothing special. This is just like random thing which I anyhow should do if I run workload on Kubernetes, and so on and so forth. That's right. You just need to use it properly. Most of the time when we have a look on how workload is configured for running on Kubernetes, it's done completely wrong. No one cares about limits and requests. Cluster autoscaling, yeah, we do something, but actually no one cares about the optimization, so we deploy just always the same amount of servers and whatsoever. This is all about, practically waste. Because as I told you before, if you don't utilize something 100%, you waste energy and you waste money for it. And the same thing for very simple, very basic configurations when you run workload in Kubernetes. So you can change, for example, your architecture, your CPU architecture for your Kubernetes, and slowly integrate, for example, ARM CPUs. They're slightly more performant, they're slightly cheaper, and they need slightly less energy. It's, again, not always a solution. Sometimes you have to change the architecture of your software for it, yes. But Kubernetes supports this. You can do that. You can run a cluster with mixed CPU architectures completely fine, no one cares. But what you do is you create the possibility for your business owner, for your product owner, to do a little step. And if you do internal cost calculation and you report internally the carbon footprint of an application, they can see, oh, wait a minute, I have to do just a little change. If I use some standard components, it's easy to switch from A to B, and I directly reduce some of my costs, I directly reduce some of my carbon footprint, without overcomplications. Another baby which I really like is something like the combination of KubeCreen and Carpenter. Because KubeCreen practically allows me to time-based deschedule workload and shut it down. That's super helpful if I have corporate internal software running around and no one works after 8, for example, like in the big enterprises. Then you can use KubeCreen and say like, oh, after 8, shut down 90% of my workload, And Carpenter will take care about the right sizing of the machines, shut down all the machines which you don't need, and you reduce all of your workload. So done in one of our customers with a combination of both of these things, saving them per week 0.5 ton of CO2 equivalent. And that's nothing, that's like 3-4 days work, maybe. So again, it's not like, oh, to become more efficient, more greener, whatever, I need to change the world. No, you just change a little bit your principles, a little bit your ideas for the engineers, what you can optimize here and there, a little bit playing around. That started as like, oh, we have a stupid idea, let's test it. Ah, it works. Okay, let's test it in production. It works. Okay, fine. Topic solved, right? 0.5 ton in 1 week, 25 tons in a year, that's okay. We can do something with that. That's something what someone likes to read, I would say, in a report. And then last but not least, we can also talk about event-driven autoscaling. In Kubernetes, you have something like KIDA. It reacts on events and scales applications up and down and so on and so forth. And you have also KIDA with a so-called carbon-aware scheduler. So it reacts on the actual market of the carbon share for the region where your workload is running in, and maybe deschedules your application in case of that the carbon footprint goes too much up. Perfect solution for Germany, right? You run your workload, blah, 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 blah. Actually, I have some arrows here. Zuck. The carbon footprint goes up. What KIDA does? Nope, you're not allowed anymore to run so much of this workload because currently it's not a good time for that. Right. Again, a more or less simple solution for also a not so complicated problem. And yes, there's super complicated software out there and whatsoever. It takes some time, we need to find out, but just try it out one day. Because the only thing which most of the time people are holding back from change is just to start some change. We can discuss about it, but we don't do it. Because we're slowly running already out of time, container caching is a thing. Think about where you put your container, how you build your container, how you store your container. Because Kubernetes has a very dirty default mechanism. If you have one of those 4 bullet points wrong, and you will have, I promise you always will pull your image to the node, even if you don't have to, theoretically. And this is just something about tags or the right set of a configuration, like image pull policy, if not present. Super important word. You can find it in almost no container definition or pod deployment file. Or container build. We have a dirty best practice out there which says like, oh, we need to run nightly builds. I'm sorry to inform you, but you're not Google. You're also not Microsoft, you're not Facebook, you're not Netflix, you're not Spotify. I'm very sorry, but you don't need nightly builds. But every nightly build consumes tons of energy. They usually takes half an hour or whatsoever. And so this is a dirty procedure part in it. But even if you want to do it, there's ways where you, for example, just replace the operating system layer. And depending on which tool you use, you either replace the complete stack, or you can just replace or update the OS, which is relevant for, let's say, bug fixes or security patches. But you don't have to rebuild the complete application layer, which is fantastic. If I have a big, heavy Go whatever app, which I have a multi-stage build, need to copy it left, right, and so on and so forth, I can just like replace the operating system for a secure version and I'm happy to go. I don't need to rebuild the whole software if I don't have to. We can skip that a little bit because I think you have heard some of those things like WebAssembly and serverless in the last days. Serverless is a really good strategy to fill up these gaps. So when I'm talking about optimizing the workload and really utilize the server as much as possible, think about to put in your random Kubernetes cluster also something to run serverless, just to fill the gaps. Maybe you have some applications that can live there. Maybe you have some jobs which can live there. That's a good way to utilize them probably. Not going into Web 3.0, even though it's interesting because what we normally can't do in IT is looking into transactions. In Web 3.0, we can look into transactions, and yeah, this helps very much to get a better feeling about how much energy is wasted. So by the way, if you pay with Visa or MasterCard, it's not so good for the planet. Maybe that's the reason why you have to pay in Berlin everything by cash. With that, talking platform engineering, create awareness, use the stuff. What about AI? Let's talk outside. But in the end, it's all about you. And as you have seen, it's just like use your brain. Sometimes it's just really like, oh, we should maybe do this configuration, and then everything is good. Or at least it's better than before. And with that, thank you very much, and wish you a very nice day, and hope you enjoy the rest of the day.